Okay. Hello all, I'm Jamna, Assistant Professor, Department of Triple St. Joseph College of Engineering. Today's session, we will see what is a Thevenin's theorem. Okay. Initially, we'll see what is the statement for Thevenin's theorem is. So, the Thevenin's theorem states that any complex network can be reduced to a simple network, okay, which will have only one equivalent voltage source in series with the resistance. Now, the equivalent voltage source, we call it as a Thevenin's voltage source, and the equivalent resistance, we can call it as Thevenin's resistance. So, let's see how does the equivalent circuit looks like. So, basically, we have a complex network. So, it could be any linear or bilateral network, the resistive load or any load we can be connecting, and this circuit can be reduced to a simple network which consists of a voltage source in series with the resistance. So I'm connecting this load as such, and this is your Thevenin's voltage source. Okay, so the equivalent voltage source is called the Thevenin's voltage source. I have denoted as VTH, and the equivalent resistance we call it as Thevenin's resistance. It is R Thevenin. So when you're doing Thevenin's theorem, we have to find out what is the Thevenin's voltage source and Thevenin's resistance. So I'll tell you the step to find out what is to find the Thevenin's voltage source, V Thevenin. So any network, if you take it, initially there are, let's take an example, and then we'll see how can we convert this into a simple network with V Thevenin and R Thevenin. Let's take three resistances. Let's take a voltage source as 10 volts, say some 2 ohms, 3 ohm, let's take this circuit with voltage source 10 volts and 3 elements 2 ohm, 5 ohm, 3 ohm, and a load resistance 10 ohm. Okay, so now we are going to convert that into a Thevenin's network. So for that, first we have to find out what is your Thevenin's voltage, V Thevenin. So to find out V Thevenin, first thing what we have to do is you have to open circuit the load and then find the open circuit voltage across the load. So we'll just draw the equivalent circuit for that. So I'm going to open circuit the load and find the open circuit voltage. Okay, this is called your V Thevenin or Thevenin's voltage source. So I'll just take the input voltage as 10 volts, 2 ohms, 3 ohms, and 5 ohm. Okay, so to find this, I have to write down, I'm going to write down, we are using the branch current method. Assume that there's a current flowing here, and I'll just put this as plus and minus because current is entering at this point and leaving here. This current is plus and minus, and entering point I'm taking plus and minus. So we are going to use our method of branch current for writing the equation for V Thevenin. Okay, so I'm starting from this point. I'm writing this as plus to minus is minus voltage across 5 ohm minus V Thevenin, and minus to plus is plus voltage across 3 ohm, that is equal to 0. So you have written this equation by using your KVL. Okay, so now you can write V Thevenin is equal to V 3 ohm minus V 5 ohm. Now if you see here, I have actually open circuited a load. So we know that the current through an open circuit is going to be 0. So voltage across your V 5 ohm will be 0 volt. So you can say V Thevenin is equal to V 3 ohm. Okay. Now let's find out what is the voltage across 3 ohm. For that you have to find what is the current through your 3 ohm resistance. So we can use the Ohm's law here. I'll take this as loop current I1. You can say 10 volts is equal to 2 into I1 plus 3 into I1, that is 5 I1. So I1 will be 10 by 5, that is equal to 2 amperes. Okay. So now we can find what is the voltage across 3 ohm, that is nothing but 3 into 2, that is 6 volts. So this is what is your V Thevenin value. Next one, we have to find R Thevenin, that is the equivalent resistance. Equivalent resistance. I'll redraw the circuit for equivalent resistance. So to measure the equivalent circuit or to find out the equivalent resistance, the step is we have to open circuit the load, close circuit the voltage source, and open circuit the load current source if there is any. Okay. So since in our circuit there is no current source, so I'm going to mark it as, so it was 10 ohm, right? So I'm going to short circuit the voltage source. Okay, that is basically I'm going to replace this voltage source into a short circuit, and from the load terminal I'm going to look back. That's the reason we call this resistance as looking back resistance. Okay, so from this terminal I'm going to look back and find what is the total resistance, that is your Thevenin's resistance, R Thevenin. Okay, so I'm short circuiting the voltage source, and 2 ohms, 3 ohm, 5 ohm, and from the load terminal I am looking back. So that is your R Thevenin. Okay, so here it is 2 ohm, 3 ohm, and 5 ohm. Okay, now we have to reduce this network and find what is the R Thevenin value. So if you see here, 2 and 3 are connected in parallel, and this whole combination is connected in series with your 5 ohm. So we can write this as 2 parallel to 3 plus 5, that is the value of your R Thevenin. So you can write 6 by 5 plus 5. Okay. So this is nothing but 6 plus 25 by 5, that is 31 by 5 ohms. Okay. Now to find out what is, so once you know what is the value of your V Thevenin and R Thevenin, we can draw the equivalent Thevenin's network. Okay. So equivalent Thevenin's network will have a voltage source V Thevenin in series with the resistance R Thevenin, and we connect our load in series with your R Thevenin. So R Thevenin, this will be RL. So V Thevenin value we have calculated as 6 volts, and R Thevenin is 31 by 5, and RL is already we have given just 10 ohm. Now to find out what is the load current IL, you can say I is equal to V by R. So you can write I is equal to, or IL, load current IL is equal to total voltages V Thevenin divided by R Thevenin plus RL. So this you can write it as 6 divided by 31 divided by 5 plus 10 ohm amperes. That is the load current of your circuit. So as I said, Thevenin's theorem is nothing but any complex, any linear, bilateral, complex network can be reduced to a simple network which consists of a voltage source in series with the resistance. The voltage source can be, we call it as a Thevenin's voltage source, and the resistance we can call it as a Thevenin's resistance or looking back resistance. Okay. Now in the complex network we can reduce to a simple network which consists of a V Thevenin in series with the resistance called R Thevenin, That is called your Thevenin's theorem. Sir, I think I can cut it. Next.